Hi, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Weather and Water. This is a student reader in Unit 2. Earth's climate. Traveling butterflies. Every fall, millions of butterflies begin a long journey. They start in Canada and northern United States. They end in Mexico or southern California. This journey can take up to 2 months. These butterflies have wings with bright orange and black patterns. They are called monarch butterflies. They fly south every year because they cannot survive cold winters. Their ideal temperature is between 0 and 15 degrees Celsius, or 32 and 59 degrees Fahrenheit. Temperature is a measure of heat. All of Earth is warmed by heat from the sun. Earth's land, oceans, and atmosphere absorb the sun's energy. This makes them warmer. Different parts of the world have different temperatures because of how they are heated by the sun. So here it's showing that the butterflies fly from north to south in the fall. Weather and climate. Monarch butterflies spend the winter in a warm climate. Climate is the average weather over a span of 30 years. Weather refers to the conditions of the atmosphere in a particular place at a particular time. For example, rain is a kind of weather. Wind is another kind of weather. Weather changes hour to hour. Climate changes over very long periods of time. Earth is divided into 3 main climate zones. These zones are tropical, temperate, and polar. They are determined by temperature and rainfall. Temperatures in the temperate zone are not too high and not too low. Rain falls year-round in this zone. The tropical zone has the warmest temperatures. It gets the most rain. The polar zones are near the north and south poles. They have the coldest temperatures. Temperatures are almost always below freezing. When monarch butterflies fly south, they travel from a temperate zone to a tropical zone. Earth's temperatures. Earth's 3 climate zones occur because the sun's rays reach Earth at different angles. This is because Earth is shaped like a sphere. Around Earth's middle, the sun's rays shine directly onto the planet. This middle point is called the equator. The equator is the imaginary line that runs around the widest part of the Earth. It is halfway between the North Pole and the South Pole. The sun's rays are the most direct here. This causes the temperatures to be high. Moving north or south of the equator, the sun's rays are spread over a larger area. This causes Earth's surface north and south of the equator to receive less direct heat from the sun. As a result, these parts of the planet have lower temperatures. Water on Earth. As the sun heats Earth, it causes water to move around the planet. More than half of the planet is covered in water. Most of this water is found in oceans as salt water. Only a small proportion of water on Earth is fresh water. Proportion refers to the relationship between things as to size, quantity, or number. Most of the fresh water is stored in frozen glaciers or ice caps. Some is stored underground as groundwater. A small amount of fresh water is found in rivers, lakes, wetlands, and the atmosphere. The atmosphere is the mixture of gases, dust, water vapor, and other molecules above Earth's crust. Earth's gravity holds the atmosphere in place. Remember that Earth's temperature range allows for water to exist in all 3 states: solid, liquid, and gas. Water molecules make up the ice found in glaciers. They make up the liquid water found in oceans. Water molecules also make up the water vapor gas that mixes with air. The water cycle. Water moves through the atmosphere depending on how much the sun heats it. With enough heat from the sun, liquid water on Earth's surface evaporates into the atmosphere. Evaporation is the process of liquid water changing into water vapor, its gas state. As the water vapor moves higher in the atmosphere, it loses heat. Eventually, it will condense. When it condenses, it changes from a gas back into liquid water. Precipitation is water falling back to Earth's surface in the form of rain, snow, sleet, or hail. These are all kinds of weather. Water that doesn't immediately evaporate back into the atmosphere will collect into lakes, ponds, and other water sources. The circulation of water from a collection to the atmosphere and back to the surface is called the water cycle. Earth's systems. The movement of water on the planet connects all of Earth's systems. A system is a set of connected, interacting parts that form a more complex whole. There are 4 Earth systems: the hydrosphere, the atmosphere, the biosphere, and the geosphere. All of the water found on Earth makes up the hydrosphere. Monarch butterflies are part of the biosphere. This system includes all living things on Earth. The butterflies depend on the hydrosphere because all living things need water to survive. As the butterflies fly south, they interact with a 3rd system, the atmosphere. All weather takes place in the atmosphere. Living things also interact with the geosphere. The geosphere is made up of Earth's landforms, including rocks and soil. Living things depend on all of the other systems for survival. At the same time, living things impact their surroundings as they breathe air, drink water, and live on Earth's surface. Weather and climate patterns. Sensing the seasons. Monarch butterflies can sense when to begin their journey south. They can tell when the days start to become shorter. The changing amounts of daylight are a sign that the seasons are changing. A season is a time of year that has specific weather patterns and amounts of daylight. Different parts of the world have different seasons and different kinds of weather. For example, the tropical climate zone has 2 seasons. Its seasons are rainy and dry. The temperate climate zone has 4 seasons. Its 4 seasons are summer, fall, winter, and spring. Earth's tilt. Earth has seasons because of Earth's movement in the solar system. As you read this, you are here on Earth. You probably feel like you are not moving, but Earth is in constant motion. Earth is always spinning. This is also called rotating. Earth rotates on an imaginary line that goes from the North Pole to the South Pole. This line is called an axis. Earth's axis is tilted. This means that it leans a little to one side. Earth completely rotates around its axis about once every 23 hours and 56 minutes. This equals 1 Earth day. As Earth rotates, part of the planet gets light and then dark. The sun always shines, but its light only hits 1/2 of the planet at a time. So here we see the Earth's axis, which is tilted, and here's the sun. So here's day in North America, and then here's night in North America. Because of Earth's rotation, it causes day and night. Because of Earth's tilt, half of Earth is always tilted toward the sun. The part of Earth tilted toward the sun gets more direct sunlight than the part of Earth tilted away from the sun. For half of the year, Earth's North Pole is tilted toward the sun. This means that the sun shines more directly on the northern hemisphere. This causes temperatures to be warmer. This is summer in the north. At the same time, the sun shines less directly on the southern hemisphere. This causes the sun's rays to spread out over more space. This is why temperatures are cooler. This is winter in the south. But it isn't always summer in the north and winter in the south. This is because Earth also moves around the sun once every year. As Earth orbits the sun, different parts of Earth tilt toward the sun. This motion around the sun is why seasons occur regularly every year. When the North Pole begins to tilt away from the sun, temperatures begin to get colder. Days become shorter. This is the beginning of fall. As Earth continues its orbit, fall turns into winter. This is because the northern hemisphere is fully tilted away from the sun. Winter has short days and long nights. It also has cold temperatures. As Earth continues to orbit, the northern hemisphere begins to tilt toward the sun again. Temperatures get warmer. The days start to get longer. This is spring. As Earth continues its orbit, summer arrives in the northern hemisphere. This is because the northern hemisphere is directly tilted toward the sun. Close to the equator, it remains warm throughout the year. This is because the sun's rays are most direct here. The two seasons are the wet season and the dry season. The wet season lasts most of the year. It is called the wet season because of how much it rains. It rains a lot in the wet season at the equator. Measuring weather. Scientists use what they know about seasons to predict weather. It isn't easy. There are many factors that influence weather. All of Earth's systems interact to influence weather. Scientists study weather data from many sources. They use weather balloons, weather stations, and satellites. They use thermometers to measure temperature. They use an instrument called an anemometer to measure wind speed. Wind speed is a measure of how fast wind is moving. Wind is moving air. Wind speed can tell a scientist how fast a storm is moving. It can also tell how much colder temperatures will feel, what we call wind chill. Scientists also report wind directions, north, south, east, or west. Measuring air pressure. Scientists also measure air pressure. Air pressure is a measure of the force of air's weight on Earth's surface. Remember that air is matter. It is made up of different kinds of atoms and molecules. Air molecules are constantly bouncing off of each other. When they are packed closely together, air pressure is high. When they spread out, air pressure is low. Air pressure can change with the temperature. Warm air rises. This causes lower pressure. Cold air sinks. This causes higher pressure. This motion of air in the atmosphere plays an important role in weather. High pressure often brings cooler temperatures and clear skies. Low pressure often brings warmer weather, storms, and rain. Weather forecasters measure air pressure with a barometer. If the surrounding atmosphere's air pressure is high, the weight of the air pushes down on the water. If the air pressure is low, the air pushes down on the water with less force. Extreme weather, flooding, the Mississippi River. Many monarch butterflies follow the Mississippi River as they fly south. The Mississippi River is the second longest river in the United States. It begins in northwestern Minnesota. It ends at the Gulf of Mexico. The Mississippi River is powerful. As it moves, it changes the land underneath it. It does this through weathering and erosion. Weathering causes rocks and soil to break down into smaller pieces. Then, moving water or wind carries those smaller pieces of rock with it. This transport of sediment is called erosion. Faster moving water can carry more sediment than slow moving water. As water erodes rock and other sediment, it carves out the river channel in the land. The sides of the channel are called the stream's banks. The bottom is the stream bed. The flood of 1927. In 1927, the Mississippi River flooded. A flood is an event that occurs when water overflows onto land that is normally dry. A floodplain is an area of land next to a stream or river that floods easily. The flood of 1927, here's a picture of it, was the most destructive river flood in the history of the United States. This flood was caused by heavy rains. These rains caused the river to overflow into the surrounding land. Water rose 9 meters high, or 30 feet, in some areas. The flood affected 10 states: Arkansas, Illinois, Kansas, Kentucky, Louisiana, Mississippi, Missouri, Oklahoma, Tennessee, and Texas. Designing a solution. After the flood, engineers came up with a solution to reduce the effects of flooding along the Mississippi. Engineering is different from science, although science and engineering are connected. Scientists use experiments to gain knowledge. Engineers use that scientific knowledge and mathematics to solve a problem by creating new technologies. Just like scientists, engineers follow a process. Engineers often follow 8 steps to guide them as they create new technologies to solve problems. The engineering process begins with a problem. The problem that engineers were trying to solve was flooding that occurred along the Mississippi River when heavy rains fell. When engineers are defining a problem, they include the criteria. The criteria are the needs the solution must meet. They also include the constraints. Constraints are ways the solution is limited. Once they have identified the problem, engineers need to research the problem. They want to find out what is known about the problem. For example, engineers need to know what floodplains flood easily. They also need to know that as water moves over the ground, it pushes sediment to the side. This creates natural levees. A levee is a natural or human-made wall that helps to keep water from overflowing a river or other body of water. Levees are usually slightly higher than the river. They are also usually parallel to the way the river flows. Levees make the banks of the river higher so the river can hold more water. A dam is another way to slow down the flow of a stream or a river. A dam is a special kind of wall that holds back water. Unlike a levee, dams block the flow of the water. After engineers have researched their problem, they survey the available materials. This survey includes a sketch of the materials. It also lists how much of the materials they have available and the properties of that material. Engineers often use soil, sand, rocks, or concrete when designing solutions to flooding. So this human-made levee is made of rocks and sand. Engineers then come up with possible solutions for how the problem can be solved with the available materials. One solution to help prevent river flooding is to design a human-made levee. Another solution is to design a dam. Engineers often consider more than one solution. They weigh the benefits and risks of each solution. They then decide on the solution that has the greatest benefit with the least risks. For example, both dams and levees can create new problems. One effect of levees is that they narrow the flood of the river. This causes the force of the moving water to be pushed through a smaller space. As a result, water levels become higher. Water flows faster. This puts more pressure on levees downstream. It can also increase the amount of erosion that takes place along the riverbank. So here's a natural river. And here's the river with the human-made levees. So you see the water level became higher. Dams have their own problems. Because they block the flow of the river, they cause water to pool behind them. This creates a new pond or lake called a reservoir. The reservoir takes up large areas of land where people can no longer live. Once engineers have analyzed the benefits and risks of each possible solution, they choose one solution. The next step is to diagram and build a prototype of the solution. A prototype is a scaled-down first draft of a technology. Once built, engineers test the prototype. They use the test to gather data. The data are measurements and observations that capture how well the prototype solves the problem during testing. Engineers test their prototype under similar conditions to see how well it holds back floodwaters compared to other designs. Finally, engineers use their data to decide whether to refine or improve or replicate or copy their prototype solution. The data tells engineers whether their prototype technology solved the problem. After the 1927 flood, the world's longest system of levees was built. There are now thousands of miles of levees along the banks of the Mississippi River. It is one of the most controlled rivers in the world. Wow, I learned a lot reading Weather and Water, and I had fun too. I hope that you learned a lot and that you had fun also. I'll see you tomorrow with another one. Bye.